Now that we have reviewed all the transformations individually, we'll look at sequences of transformations when we can get multiple transformations in the same problem. On page 291 of your textbook, it'll start to introduce this topic, and you'll see this summary of transformations, which is what I just showed you in the file that I've uploaded to our Blackboard site. On the next page, you'll see this order of transformations, which I referred to briefly earlier in our work in 2.5 Part 1. But when we have a sequence of transformations, there's an order that we're going to process them. Again, I used a recipe analogy, right? What ingredients do you have? How do you basically cook the meal? What transformations do you have? What order do you do them in? And so this is why it's important to set up the problem. Identify the transformations in what order that you will do them in the problem. And so our order is as follows. We'll do horizontal shifts first, any stretching or shrinking second, reflections third, and then we'll do vertical shifting fourth. So let's look at example 8. And this is going to utilize that same generic function f of x that we worked with doing the horizontal stretch and shrink example that I did in the previous video. So in example 8, they give us a generic function f of x that we use we'll obtain coordinate points for from the graph in the textbook. And so particularly in a problem like this, where you don't know the actual algebraic function you're working with, you really need to look carefully at the transform function and identify what transformations you have in that function before you get the problem started. So if we take a look, here you can see there's a -1 that's inside the argument of the function. That's a horizontal shift. So that'd be the first thing we do. So this is a horizontal shift right 1 unit. And what's our algebraic manipulation? We will add 1 to the x coordinates. So that's really the first key manipulation we'll make. And then our second transformation is, if you take a look, we have a -1/2 out here front. The 1/2 is the vertical shrink, or the vertical shrink. So we'll have a vertical shrink. And what we will do is multiply the y coordinates by 1/2. Now next you'll see that there's a negative sign. Again, that's outside, just like the 1/2, it's outside the argument of the function. So we know it's a vertical transformation. In this case, a vertical reflection. And so I will change the sign of the y coordinates. And then lastly, you'll see the +3 here at the end of the function expression here. That's a vertical shift. We'll do that last. So that is a vertical shift up 3 units. I will add 3 to the y coordinates. So it's very important in these more complex problems with the sequences that you do all this work to set up the problem so you can execute it correctly. So we have our points f, x, and f of x that we got from the graph, and let's start to work through the transformation. So horizontal shift right 1 unit, add 1 to the x coordinates. So this will be my first step, and I'll just use some intermediate letters for the intermediate functions. We're going to have multiple table of coordinates. Now, in this case, we're changing x, but not y. So I'm just going to copy the y values down. But we're going to add 1 to the x values. So this would be -3, -1, 1, 3, and 4. And then our next manipulations, now sometimes it depends on how the problem works out, but if you look at the vertical shrink, if you look at parts 2 and 3, we're both multiplying the y coordinates in each step. So this doesn't happen in any problem, but one thing you could do, because you're multiplying the y coordinates in each step, we could combine these and multiply by -1/2, right? We're going to multiply by 1/2 and then multiply by -1. We can do that in one step to be a little more efficient if you'd like. So I'll call this step, say, 2-3. Now we'll have x, and I'll call this maybe h of x. So now we're not changing x, so I'll copy those values down. But we will change y. We'll multiply these values by -1/2. So this will be 0, -2, 0, 1, and 0. And now lastly, we have the vertical shift, where we'll add 3 to the y coordinates, and I'll just call this x and maybe m of x. This will be the final table of coordinates. Now we're not changing x, so I'll copy those. And now let's add 3 to this column that you see in red. And let's see, so this would be 3 and 1, 3, 4, and 3. When you look at the solution in the text, of course the text isn't going to show you the tabular method that I have. It'll really go through the solution more graphically, but they will do the horizontal shift right 1 unit, then they'll do the vertical shrink, then they'll do the reflection, and eventually get to the final function. But note, we go through all those steps individually with our tables, but if you look at the final table of coordinates, right, -3, 3, -1, 1, 1, 3, 3, 4, and 5, 3. Again, we can determine all the final coordinate points first without ever doing any graphing or intermediate graphing. So this is an important example, particularly when you're not working with one of our common functions, right? You have to get your 5 starting coordinate points from some other function or a graph, and then work through the manipulations to get to the final answer. Let's look at one more example, example 9, that will involve a sequence of transformations, but in this case, we're going to use one of our common algebraic functions, f of x equals x squared, to graph g of x equals 2 times x plus 3 squared minus 1. Again, let's identify the individual transformations we have and identify what sequence we need to do them in and what the manipulations will be. So if we see here, this 2 is outside the argument of the function. That's really going to be a vertical stretch. Here, this plus 3 is inside the argument of the function. That's a horizontal shift. Remember, that's really a shift left 3 units. And then this is a vertical shift, down 1 unit. So let's identify those transformations, and then we'll get to the table of coordinates. So here, first thing we'll do, right, horizontal shift left 3 units. And so what we'll do is subtract 3 from the x coordinates. Right. Second thing we'll do is this vertical stretch. And that manipulation is we will multiply y coordinates by 2. Right, so there's that manipulation. And then third, we have a vertical shift down 1 unit. And so we will subtract 1 from the y coordinates. So again, very important to set up these problems when you have the sequences. So as always, we'll start with the coordinates of the base function, which in this case is the x squared function. So we can have our 5 typical x values. We square them, right? 4, 1, 0, 1, 4. And now the first transformation, let's just take a quick look. Right? Horizontal shift left 3 units. We'll subtract 3 from the x coordinates. So I'll just call this, maybe I'll call this h of x for this step. Right, so notice we're not changing y, so I'll copy over those values. But we'll subtract 3 from the x column, right? Minus 5, minus 4, minus 3, minus 2, and minus 1. And then part 2. Manipulation 2, vertical stretch, multiply y coordinates by 2. So I'll just call this x and maybe k of x. So now we're changing y but not x, so I'll copy the x values. And let me write this in red. So now we're going to multiply the y values by 2, so this should be 8, 2, 0, 2, 8. And then the third transformation is that vertical shift down 1 unit. So last table of coordinates, x, that's g of x, the letter they wanted. Now again, we're not changing x, so I'll just copy those over. And now we'll just subtract 1 from this column. So this would be 7, 1, minus 1, 1, and 7. When we look at the solution in the textbook, again, they're not going to show you the table of coordinates. They'll sort of show it to you graphically. But as we follow along the sequence, right, we do the horizontal shift, the vertical stretch, and then the vertical shift down, and you'll see the final graph here. And of course, looking at our final table of coordinates, you'll see at least 3 of the points there, right? Minus 5, minus 7. There's the minus 1, 7, the minus 3, minus 1. And the other points are there as well, right? Minus 4, 1, and minus 2, 1. So what I'd like everyone to do as some extra practice is I would like everyone to do checkpoint 8 and checkpoint 9. Oops. Now, checkpoint 8 is going to use a graph out of the textbook that's sort of a generic function f of x, not one of our common algebraic functions. So let me put those coordinate points here to use for checkpoint 8. So I'll just abbreviate here. So checkpoint 8, here's your coordinate points for x and f of x to get started. So you'll have minus 2, 0, 0, 3, 2, 0, 4, minus 3, and 6, 0. Right. Checkpoint 9 will use the quadratic function, just as I showed you in example 9. So that one you'll know the points for, but use this table of coordinates to get started in checkpoint 8.